Let us discuss the theory of production today. Now, what is the concept of production? Neoclassical definition of production is the most commonly accepted definition of production today. According to the neoclassical theory, production is an economic process of combining various material and immaterial inputs to make something for consumption. That is the output. It is the act of creating output, a good or service, which has value and which contributes to the utility of the individuals. Production takes place within the farms. A farm is a unit where inputs are employed and outputs are produced. Therefore, a farm can be characterized by many factors and aspects such as sectors, scale of production, ownerships, and organizational structures. The key characteristic of a farm is that it is the producing unit of the economy. A neoclassical farm buys inputs, converts them to outputs, and sells these outputs to the consumers, farms, and government. The goal of the farm is to maximize profit. Now, let us discuss about the factors of production. A factor of production is an economic term to describe the inputs that are used by the farm in the production of goods and services in an attempt to make economic profit. The factors of production include land, labor, capital, and organization. Land represents all natural resources such as plots of land and timber used in the production of a good. Labor is the service that laborers and workers perform at all levels of a production process except for the entrepreneur. The capital is defined as the man-made tools and equipment used to produce a good or service. The organization is the task performed by the entrepreneur in the form of innovative ideas to make profit from the production process by combining all the other factors of production. The entrepreneur also takes on all of the risks and uncertainties of the business. Land and labor cannot be produced since land is a gift of nature and labor is the inherent quality of a person. So therefore these two inputs are called primary inputs. On the other hand, capital and organization are goods and services that can be produced. Therefore, these two inputs are called secondary inputs or secondary factors of production. Now, what do we mean by a production function? A production function relates physical output of a production process to physical inputs or factors of production. It states the maximum quantity of output that a farm can produce using different combinations of inputs. There are four factors of production, that is land, labor, capital, and organization. However, in practice, while defining production function, we assume that amount of output produced depends on labor and capital, and the other factors of production remain constant. If the amount of output produced is capital Q and the amount of labor and capital used in the production process are L and K respectively, then the production function can be written as Q is a function of L and K. This implies that quantity of output Q depends on quantities of inputs L and K. For a particular value of L and K, we get a particular value of Q, which represents the maximum amount of output Q that can be obtained from that particular input combination. Now, what are the short run and long run production functions? The character of a production function changes according to the time available for the production process to be completed. The total time available for production can be divided into two periods, short period or short run and long period or long run. According to the time available, there can be two types of production function, short run production function and long run production function. The short run is the longest period of time during which at least one of the inputs used in the production process cannot be varied. The input that cannot be varied in the short run is called fixed input, while the input that can be varied in the short run is called variable input. If we assume that in the short run the farm cannot vary capital and labor is the only variable input, then the short run production function will be Q equal to function of L and K bar, where L is the variable labor input and K bar is the fixed capital input. Now long run is the shortest period of time required to alter the amounts of all inputs used in the production process. That is why we can safely assume that in the long run the firm can vary both capital and labor, and the long run production function will be simply Q equal to function of L and K. There is no bar, so both L and K are the variable inputs. Now we will discuss about the concepts of total product, average product and marginal product. Total product means the total amount of output produced by the firm using both the fixed and variable factors. In the short run, the amount of fixed factor remains unchanged. Therefore, using different amounts of the variable factor, the firm can produce different amounts of the total product. Therefore, in the short run, amount of product, total product, would depend upon the amount of the variable factor employed in the production process. Now, what is average product? Average product of any factor is the amount of output produced by one unit of that factor. It is the ratio between the total product and the amount of the factor. If we denote total product by Q and labor by L, then average product of labor will be Q by L. Marginal product. The marginal product of any factor is the change in the total product due to one unit change in that factor. In the short run, the firm can change only the variable factor. Therefore, in the short run, marginal product is the change in the total product due to one unit change in the variable factor. If we denote change by delta, then marginal product of labor will be delta Q by delta. Now, what is the law of variable proportions? The short run production function has an important property. It follows the law of variable proportions. According to the law, with a fixed technology, as the quantity of the variable input continuously increases, quantity of fixed input remaining the same, total amount of output first increases at an increasing rate, then beyond a certain point it increases at a decreasing rate, and finally it increases at a negative rate. That means it decreases. So the relationship between total product, average product and marginal product is based on the law of variable proportions, and therefore average product curve, marginal product curve and average product curve and marginal product curve can be derived from the total product curve. Now here we can show how the average product curve and marginal product curve are derived from the total product curve. In the upper panel, we are showing the total product curve. The total product curve is OTP, where first of all from O to S, from the point O to point S, the total product increases at increasing rate. This is the first stage of production. Then from S to M, the total product increases at a decreasing rate. This is the second stage of production. And then at point M, the total product reaches at its maximum. And after that point, the total product decreases. That is the stage 3 of production. Now there is a point of inflection which is denoted by Q here, which shows now from this total product curve we can derive the marginal product curve and average product curve. Now from Q to S, since the total product curve increases at an increasing rate, average product will increase, and up to the point of inflection, marginal product will also increase, and marginal product will be higher than average product. Marginal product will reach at its maximum point at point P, which is corresponding to the point of inflection Q. After that, marginal product will go on decreasing, but still average product will go on increasing, and it will reach at its maximum at a point which is corresponding to the point S. After that, since the production reaches its second stage, and at this stage the total product will increase at a decreasing rate, therefore marginal product will be falling and total average product will also be falling. Now after that, when total product reaches at its maximum at point M, the marginal product will be 0. That means marginal product curve will intersect the horizontal axis, and after the point M, total product curve will decline, and therefore marginal product curve will be negative. It will go beyond the horizontal axis from point T downwards. So in this way we can see that we can derive from the total product curve, the marginal product curve, and the average product curve. And when average product curve is increasing, marginal product curve is also increasing, and it lies above the total average product curve, and it reaches at its maximum before the average product curve reaches at its maximum, and then marginal product curve is falling, although average product curve is still increasing. And when average product curve reaches at its maximum, average product becomes equal to marginal product. That is, two curves intersect each other, and then after that marginal product goes on declining, and then after beyond a certain point it is negative. So in this way we can derive these three curves. Now let us discuss about the concepts of total revenue, average revenue, and marginal revenue. Total revenue is the amount received by the seller from the sale of a quantity of commodity sold in the market. Total revenue is obtained by multiplying the price of the commodity with the quantity of the commodity sold. Total revenue is equal to price into quantity, that is TR equal to P into Q. Now, average revenue is the average receipts from the sale of a certain units of the commodity. It is obtained by dividing the total revenue by the number of units sold. That means average revenue is equal to total revenue divided by quantity, that is AR equal to TR divided by Q, which is equal to P into Q divided by Q, that is P. So average revenue is equal to price. Now marginal revenue is the additional revenue generated from the sale of an additional unit of output. It is the change in total revenue from sale of one more unit of a commodity. Now symbolically marginal revenue can be written as DTR DQ, where D represents a change. Now, relation between total revenue, average revenue, and marginal revenue can be depicted in this table. To discuss the relation between TR, AR, and MR, let us first assume that the price of the commodity is fixed. The firms can sell any amount of output at this price. This is a perfectly competitive market. So therefore, in a perfectly competitive market, there are a large number of firms, and each firm is a price taker. If the firm is a price taker, that means price or average revenue remains the same when more and more units of a product can be sold. So MR will be equal to AR, and this can be explained with the help of the table. Now here we can see that price is fixed at 15 rupees for all the units of the commodity sold. As the more and more units of the commodity is sold, total revenue can be calculated from here, and we can see that average revenue, that is TR by Q, and marginal revenue, that is derived from subtracting the earlier amount of total revenue from the next amount of total revenue, and we can see that both the average revenue and marginal revenue become same, and which is equal to price. So in a perfectly competitive market, price is equal to average revenue, which is equal to marginal revenue, and total revenue goes on increasing. So this relationship can be depicted in the diagram. Total revenue goes on increasing. It is a upward rising straight line, whereas the average revenue and marginal revenue is the same, which is the fixed horizontal curve for the fixed price P0. Now if we assume that the price of the commodity is not fixed, that is the market is not perfectly competitive market, that means in order to sell more units of a commodity, the firms can reduce the price because the firms are no longer price takers. So when there prevails an imperfect competition in the market for a product, the individual firm producing that product faces a downward sloping, as usual, downward sloping demand curve. And this table explains how marginal revenue can be obtained from changes in average total revenue and the relationship between marginal revenue and average revenue. Here we can see that as number of units sold is increasing, price is decreasing, and we can calculate the total revenue, which goes on at first it increases at an increasing rate, then it reaches at its maximum, and then it decreases. At first it increases, then reaches at its maximum, and then decreases. And average revenue goes on declining, and marginal revenue also goes on declining. And we can see that marginal revenue becomes negative after a certain point, after a certain amount of units sold. So this can be depicted here, that the total revenue curve is first of all increasing, and then it reaches at its maximum at the point A, and then total revenue is declining, and both the average revenue and the marginal revenue curves are declining. And when average revenue curve is declining, marginal revenue curve is also declining, but it is less than average revenue, and it becomes zero, and eventually it becomes negative after a certain amount of output. So now let us discuss about the relationship between AR, MR, and elasticity of demand. We can get that relationship using a mathematical method. Now, if the price of any commodity is P and quantity sold is Q, then TR is equal to PQ, and average revenue is equal to PQ divided by Q, which is P. So average revenue is always same as price. Now suppose initial price and quantity are P and Q respectively, and we also assume that initial total revenue is TR0. So TR0 equal to P into Q. Now let the price fall by delta P, and as price falls, quantity will increase by delta Q. So now the total revenue will be TR1, which is equal to P minus delta P into Q plus delta Q. Therefore, change in total revenue, that is delta TR, will be equal to TR1 minus TR0. That is P minus delta P into Q plus delta Q minus P into Q. And solving this equation, we can get that delta TR is equal to P delta Q minus Q delta P minus delta P delta Q. Now delta P delta Q is infinitesimally small. It is very small, so it can be ignored. So delta TR can be written as P into delta Q minus Q into delta P. Now marginal revenue is defined as the change in the total revenue consequent upon a change in output. That is, marginal revenue is equal to delta TR by delta Q. That is, putting the values of delta TR and delta Q here, we can get P MR is equal to P minus Q into delta P by delta Q. Now we multiply P in the right hand side, and how can we do that? MR equal to P into 1 minus Q by P into delta P by delta Q. Now this is none other than 1 by E. So P, which will be equal to, then MR will be equal to P into 1 minus 1 by E, since delta Q by delta P into P by Q is equal to E. That is why we can get the 1 by E. So MR is equal to P into 1 minus 1 by E. Now P is nothing but AR. So MR equal to AR into 1 minus 1 by E. So this relationship, MR is equal to AR into 1 minus 1 by E. Using this relationship, we can calculate the value of MR at any point of output, at any level of output from the AR at the same output. So provided we know that the point price elasticity of demand on the AR curve. So we have to know the value of the point price elasticity on the AR curve. In an imperfectly competitive market, AR or the demand curve will be downward sloping straight line. With the help of the following figure, we can obtain the values of MR at different points of the AR corresponding to the different points of the MR, if we know the values of the point price elasticity of demand. Now as we can see that at the D dash is the AR curve or demand curve, and at the midpoint P, elasticity is equal to 1. Therefore marginal revenue will be equal to 0. Now in the DP segment, elasticity is greater than 1. That means 1 by E will be less than 1. So marginal revenue will be greater than 0. At the segment P D dash, elasticity is less than 1. That means 1 by E will be greater than 1. So MR will be less than 0. And at point D, elasticity will be infinity. That means 1 by E will be 0. That means AR will be equal to MR, which is the case of the perfectly competitive market. And at point D dash, elasticity is 0. That means 1 by 0 will be infinity. So AR will be infinitely less, MR will be infinitely less than AR. So that is the relationship between MR and AR, and in this way we can find out the value of marginal revenue from the average revenue curve if we know the values of the point price elasticity of demand at different points of the average revenue curve.